Algebra 1. Here are your notes for 12.7, Day 2, where we were adding and subtracting rational expressions with unlike denominators yesterday. We're going to keep building upon that concept today. So what happens when the denominators and or the numerators are more complicated monomials or even binomials? Well, the first thing I always suggest is simplify first. Don't jump in and use your methods until you see if you can make the problem easier before doing your computations. For example, in this first one, when I look at this first fraction, there's nothing that can really be simplified there. But if I look at the second fraction, I see a lot of 4s and 8s, which I know are all divisible by each other. So one thing I'm going to do before I even get started, I'm going to pull the problem over here. N plus 3 divided by n. If I factor out a GCF of 4 on top, that changes how the problem looks. It doesn't change the actual fraction, but how it looks. So in this case, if I divide out a 4, I'm left with a 2n minus 1 all over 4n. Now that may seem really small, but you'll notice 4 divided by 4 reduces to a big fancy 1. We like that because now we have an n on the bottom of this fraction and an n on the bottom of this fraction. So instead of having to multiply or get a like denominator, I already have one just by doing that little trick and by reducing. So I go a step further. Because they're both over n, I can just add or subtract the numerators. In this case, I'm adding n plus 3 plus 2n minus 1 and get my numerator. So n plus 2n is 3n. 3 plus negative 1 is positive 2. I can't simplify this any further, so that's my answer. Let's take a look at the next one here. Same thing. I'm going to look at this first one and say, can I reduce this at all? Or can I change how it looks? Well, I look at the bottom here and I see that x squared and 4x have an x in common. So I'm going to rewrite this as 3x divided by x outside of x minus 4. All I've done there is factor out what they have in common, which is an x. I now see that I've got x divided by x, which turns into a big fancy 1, or cancels out. Some of you like to think of it that way. And I'm left with just 3 divided by x minus 4. Because my second term is just 1 over x minus 4, since I have a common denominator, it's really easy to just then subtract. 3 minus 1 is 2. They have the same denominator. I can't simplify any further, so that's my answer. Now, I wish I could say that all unlike denominators were that easy. Unfortunately, they're not. So things like this, examples 3 and 4, we may not be able to reduce, but we may have to multiply. So let's look at this one here. I do see that they have something in common. I'm going to bring that down here and simplify it to be, they have a 2 and an x in common, so 2x on the outside, and I'm left with x plus 3 on the inside. Second term, I can't really reduce it at all, so I have this. Here is where we're going to need to go back to yesterday, where we find their least common denominator, and then make that the entire denominator. So in this case, when I write this out, this is 2 times x plus 3. This one is x times x. Remember, I'm going to take the most occurrences of each side. So in this case, 2 occurs most just in one instance. Between x and x squared, I have to take both x squareds. That's the one where it occurs most. And then I only have one x plus 3, but I do have to take it. I now have my least common denominator. But now I can't just add the tops because those aren't the same. So how do I have to change this denominator to get it to be 2x squared times x plus 3? Well, since it's already 2x, I just need to multiply it by another x to get a common denominator, but you'll see whatever I do to the denominator, I also have to do to the numerator, which I've already done. Same thing over here. I've got the x squared, but I don't have the 2 or the x plus 3. So I'm going to have to multiply this side by 2 outside of x plus 3. And yes, you do have to write it outside because that's in parentheses. So let's now do that and rewrite these so that both have the common denominator shown here. This one's going to be pretty easy because it's 1 times x all over that common denominator of 2x squared times x plus 3. Second one's a little bit harder, but not supremely. It's going to be plus 3 times 2 times x is 6x. 3 times 2 times 3 is going to be 18, so I have 6x plus 18 over that common denominator that we like, that we crafted. And now that they have the same denominator, I can add them. In this case, even easier because we've got 6x plus x. Let's make some equal signs here. 7x plus 18. And then when I jump down here to the bottom, I'm just going to simplify this in the process because I know nothing will end up canceling. You can't change that or simplify it or rewrite it in any way to reduce these numbers. So 2x squared times x is 2x cubed. 2x squared times 3 is 6x squared. Like I said before, we can't reduce, so that's my answer. I know it's a lot of steps, but as long as you learn those steps and you practice them, the actual steps themselves are not that tricky. So let's see another one here. Again, I'm going to simplify, so let's bring this left fraction over. I need to simplify the bottom part, meaning I need to factor it. X squared plus x minus 6 becomes x and x. What two numbers multiply to negative 6 and add to positive 1? That would be positive 3, negative 2. I'm going to then simplify this right one. I have x minus 2. This bottom, if you didn't notice, is a difference of squares, meaning we unsquare the first, goes in the first blank, unsquare the second, goes in the second blank, and then we change the signs. Notice when I do that, this one can't be simplified at all because everything is closed into its parentheses. But this one, if I add parentheses to the top just for looks, I have x minus 2 over x minus 2, which reduces to a big fancy 1. Now when it cancels out on top, you might think that there's nothing up there, but remember, this is technically multiplied by a 1, so when the x minus 2 cancels, all that's left is 1. So we now have this first term, I'm not going to rewrite that, minus 1 over x plus 2. Now, at this point, we have an x minus 2, an x plus 3, and an x plus 2 all on the bottom. None of those are in common, so we're going to have to do the same thing we did in this last problem, find the LCD, least common denominator. Let's go through what we have here. On this side, the most that x minus 2 occurs in either term is once. So I'm going to take the 1 time. X plus 3 only occurs once in the first one, so we have to take it. And x plus 2 only occurs once in the second term, so we also take that. A lot of terms going on there. Now that we found the LCD, we follow our steps from yesterday. We're going to multiply each side by whatever it is missing. So this one is missing an x plus 2. So we're going to multiply by x plus 2 on the top and on the bottom. This one has the x plus 2, but it's missing these, so we're going to multiply by that on the top and the bottom. All right, bear with me. This one's pretty simple. When we multiply to the top, we get x squared plus 2x over our common denominator. I'm not going to rewrite it. 1 times the x minus 2 times x plus 3 just becomes that. And for the sake of ease, I'm going to multiply that as I go. So x times x is x squared. I already know what this is actually. It's x squared plus x minus 6 because I already did that math up here, all over that common denominator. And now I can subtract. But recall, in one of my videos, or in many of my videos actually, I said that if there is a subtraction sign between your fractions, we have to make sure we distribute that sign to all the terms inside of the parentheses. So the way that I'm going to rewrite my final step here is I know when I subtract, it's going to all be over x minus 2, x plus 3, x plus 2, and then I'm going to rewrite my numerators together. So it's going to be x squared plus 2x minus x squared minus x plus 6. And then I simplify. X squared minus x squared, those cancel. 2x minus x just becomes x. And positive 6 just stays positive 6. So I have x plus 6 all over my LCD, which is shown here. So when I rewrite my final answer, I'm going to get x plus 6 all over x minus 2, x plus 3, x plus 2. And there's nothing I can simplify except your ability to see the problem. So that is my final answer. As you can see here on the bottom, I wrote pause here and try the backside problems, so that is exactly what I would like you to do before continuing the video. Give those a shot and then come on back, we'll do them together. Alright, hopefully you had a moment to pause the video. We're going to jump right in with these problems. So, let's go. I notice I have 4 divided by h plus 1 plus 2 divided by h plus 2. I am going to start skipping some of those middle ground steps to show you how to simplify in your head a little bit. But if that is too challenging or I'm going too fast, feel free to email me. I would love to send you the worked out problems with all of the steps, or even just go through and show you together. So with this one, I have h plus 1 on the bottom. Over here, I have h plus 2. I noticed that my LCD is going to end up having one of each of those. So I right away can tell that my LCD is h plus 1 times h plus 2. And I notice that each of the tops is just going to be multiplied by the other, because essentially this one's missing h plus 2, this one's missing h plus 1. So when I rewrite the problem and multiply by what it's missing, this one is just going to be multiplied over here. So in this case, I'm going to do this, maybe I'm not going to do it all in one step, but if I know it's all over the LCD, this is going to be 4 times h plus 2, because that's what it's missing. So on the left, we're going to get 4h plus 8, distribution. This problem is missing an h plus 1, so that's what we're going to multiply by over the LCD. This one's over the LCD. So the right-hand side becomes 2h plus 2. And then what I really like about addition problems is that I can just change the whole thing into a fraction, move the plus up, and then put it all over the LCD, which we already know is h plus 1 times h plus 2. Then let's simplify the top. 4h plus 2h is 6h. 8 plus 2 is 10. All over h plus 1 times h plus 2. Quick check, if I divide anything out of here, I'm going to get a 2 times 3h plus 5, which doesn't cancel out with the bottom. So I can either go ahead and FOIL here to make this into one trinomial, or I can leave it this way. I don't really have a preference, but because I like to FOIL, I'm going to go ahead and do that. So h squared plus 2h plus 3h plus 2. Since I can't simplify like I said before, that one's done. Next up, I notice right away that I can rewrite this left term as h over 6 times h plus 1. That's really convenient because now I can just multiply the right-hand side by 6 over 6 in order to get a common denominator of 6h plus 6. The left side doesn't change at all. The right side becomes minus 6 on top. So when I rewrite this, it looks like this. Minus 6 over 6h plus 6. Now I can just simplify to be h minus 6 on top over 6h plus 6. We can't reduce this at all, so there's our final answer. The next couple are getting trickier, but only because they look trickier. We're still just going to follow the same steps we did before. Simplify if you can. In this case, I'm going to factor the denominator so that I can see what is kind of hiding in this problem. I've got a y plus 1 and a y plus 2. When I factor the right side, I have a y plus 1, a y plus 1. So now, in order to get a common denominator, this one is just missing another y plus 1. This one is just missing a y plus 2. So I'm going to put that y plus 2 over here. I need a y plus 1 over here. When I do that, I'm going to make it, common denominator, y plus 1, y plus 1, y plus 2. So you'll have 3 terms on the bottom. When I multiply the top, I get 2y plus 2 over the LCD. Not going to rewrite it. Minus, we simplify this side to be 4y plus 8 over the LCD, least common denominator. And then simplify. Remember, because you have a subtraction sign, you have to distribute it to all the terms of the numerator. So I get 2y minus 4y, that's negative 2y. I get 2 minus 8, negative 6, all over the LCD. In this one, I am going to write y plus 1, y plus 1, and y plus 2. I do a quick check. If I factored out the negative 2 from this one, I'd get y plus 3, which doesn't cancel here. Tells me I can't simplify, so that's my final answer. And then the same thing with the next one. Essentially, I'm going to simplify the bottom. This is a difference of squares, so it's q plus 4 times q minus 4. This one, when I factor it, is q plus 4, q plus 1. Yep. This one's missing the q plus 1, multiplied by the top and the bottom. This one is missing the q minus 4, multiplied by the top and the bottom. And it looks like this. Multiply by the top, I get q squared plus q over the LCD. Plus this one, because it's a binomial times a binomial, it's going to be a FOIL. So let's do that. Q squared, I get negative 3q minus 4 over the LCD. It's an addition problem, so I'm not worried about distributing negatives. So let's quick check. Q squared plus 2 plus q squared is 2q squared. Q minus 3q is negative 2q minus 4 all over the lovely q plus 1, q plus 4, q minus 4. Using q as a variable really tricks me sometimes. Do a quick check, make sure there's nothing that you can simplify here. In this case, if I pulled a 2 out of all of these, I'd have q squared minus q minus 2. I don't think I could simplify that any further, so that's my final answer. Not all of these are going to look real nice when you do them, so don't freak out if you end up with a really big answer. That's totally okay. All right, last one. In this one, I have two things to simplify because this 3x minus 6 can be simplified as well. It's not always just the numerators or the denominators. Sometimes it can be both. I'm going to change this bottom to be x plus 1, x plus 2. This bottom becomes just x plus 2, x plus 2. But I notice the top also changes to be 3 outside of x minus 2. That doesn't really help me at all because nothing cancels, but it's good to double check just to make sure. And from there, same thing as always. This one is missing a second x plus 2 to the top and bottom. This one is going to be missing an x plus 1 to the top and bottom. So let's do that. 3x squared plus 6x over the LCD, which in this case is going to be 1, 2, 3 terms, minus, I can do the x plus 1 just into this one, or I can leave it that way. It doesn't really matter. I'm going to do it to this one, not to our simplified version. All right, so when I FOIL, 3x squared plus 3x minus 6x minus 6 all over the LCD. Remember, we are subtracting, so once I simplify these inner two terms to be negative 3x, I distribute to each of the three terms and simplify. So 3x squared minus 3x squared cancels. 6x minus negative 3x would be positive 9x. And then 0 minus negative 6 would be positive 6. All over the LCD, which is going to be x plus 1 times x plus 2 times x plus 2. I can pull a 3 out of both of these, but it's not going to simplify nicely because that would be 3x plus 2, which doesn't cancel. So because I can't simplify any further than that, this is my answer. I know that was a lot, but most of it is just making sure that you simplify first and then distribute your negatives when appropriate. If you have any questions, let me know.